Let's configure spanning tree protocol in our topology. How many VLANs do you see? Well, I see VLANs 10, 20, 100, and 200. But let's take a look at DSW1, show spanning tree. There's VLAN 1 running rapid spanning tree protocol. What else do we have? VLAN 10, VLAN 20, VLAN 99, VLAN 100, and VLAN 200 for a grand total of 6 VLANs. So we have 6 separate spanning tree instances running right now. However, we are creating the same spanning tree topology for some of these VLANs. For example, VLAN 10 and VLAN 100 use the same root bridge, DSW1. Therefore, they create the exact same spanning tree topology. We have VLAN 20 and VLAN 200 using DSW2 as the root bridge. Therefore, those two VLANs create the exact same spanning tree topology. So by using multiple spanning tree protocol and by grouping these VLANs together in instances whereby they have the same spanning tree topology, we will reduce the number of spanning tree instances that are running here. So let's go ahead and do that. Let's start off by going into global configuration mode and then entering spanning tree, MST configuration mode. And we will start off by configuring the name. So the region name, we'll call it switch in this case. We'll specify the revision number. The revision number we'll use is 3. Doesn't matter what you use, it doesn't dynamically change. All that matters is that you have the same revision number on all the switches in your region. So DSW1, 2, ASW1 and ASW2 need the same region name and the same revision number. In addition, they need the exact same instance to VLAN mappings. So let's create instance 1. And in instance 1, we're going to place VLANs 10 and 100. So 10, 100. And let's create instance 2. In instance 2, we will place VLANs 200 and 20. So that is our basic MST configuration. So let's go back to global configuration mode and we'll type in show run pipe to section spanning tree. And when we look at the output here, we'll see that the configuration is right here. So since the configuration has to be the same on DSW2, ASW1, ASW2, let's copy and paste it. So we'll copy from DSW1 and paste it onto ASW1. We'll do the same thing on ASW2. Go in the global configuration mode and paste it. And DSW2 will do the exact same thing as well. So now all of these switches have the exact same MST configuration. When we enable MST by typing in spanning tree mode MST in global configuration mode, all of these instances, so instance 1, instance 2, and let's not forget about instance 0, the internal spanning tree instance, it will, or all 3 of them, will elect the exact same root bridge, which is going to end up being ASW2. Because ASW2 has the best bridge ID out of all of my switches by default. So if we want to manipulate the root bridge here on an instance by instance basis, we have to change the priority of those switches that we want to become the root bridge for the various instances. So let's just manipulate instance 1 and instance 2. I want DSW1 to be the root bridge for instance 1. So on DSW1, we'll type in spanning tree MST1. So I'm specifying the MST instance here, not the VLANs, like we would with per VLAN spanning truss or per VLAN rapid spanning tree protocol. So spanning tree MST1. And we'll say, in this case, priority 0. Now you could have used the root primary command. It would elect it as the root bridge in this case, but I like giving my switches the best chance of maintaining the root bridge role if a rogue device comes along announcing a lower priority. 0 is the lowest priority, so the only way that switch could take over would be if it had a lower MAC address on top of having a priority of 0. So I'm giving DSW1 the best chance. All right. What about DSW2? We want DSW2 to be the root bridge of MST instance 2. So we'll type in spanning tree MST instance 2, and it's going to have a priority of 0 as well. All right, so all that's left now is to enable MST. On DSW1, if we type in show spanning tree, so do show spanning tree MST, we can see here that the switch is not in MST mode. So to do that, we type in spanning tree mode MST. We'll do that on all the switches. Spanning tree mode MST. Spanning tree mode MST. And lastly, spanning tree mode MST. So once it cooks in the background, we can see that we had a little bit of blocking going on because of our spanning tree protocol features, but it's clearing itself now. So this is not something you want to do on the fly in the middle of the day, because by doing so you could disrupt the network. Make sure you plan an appropriate time to transition from rapid spanning tree protocol over, or spanning tree protocol over to multiple spanning tree protocol. Now look at this. See, we have a problem. Something happened here. It's not happy. I have some MAC flapping going on within my topology. I think we might have a problem. Let's see, with VLAN 10 here between port 105 and 102. Let's take a look here. Let's just type in do show span for VLAN 10. Let's just see if we can find anything. Designated forwarding. It's the root bridge. All right, looks good so far. Do show span for VLAN 10. I was not expecting this, folks. Oh, look at this. I think that we found our problem. We have gigabit 102 as an alternate port in the forwarding state. You see that? Let me show you again. It's an alternate port in the forwarding state. Whoa, alternate ports are not supposed to be in the forwarding state. So I implemented multiple spanning tree protocol, but something's happened here, and spanning tree protocol has essentially failed. We have an alternate port in the forwarding state. So what I'm going to do here really quickly is go into interface gigabit 1/0/2, and let's shut it down. Let's shut it down, and let's see if that stops this MAC flapping from going on. Right, so far so good. It looks like we have cleared the problem in this particular case. Let's re-enable it and see if spanning tree protocol sorts itself out now. And let's see if that alternate port goes in the blocking state. So my fingers are crossed. My fingers are crossed. Okay, so the interface is up. Let's take a look at spanning tree for VLAN 10 just as an example. Good. Whew. The alternate port's in the blocking state now. The loop is gone. We no longer have the MAC flapping, the broadcast storm that was happening there. So we were able to sort ourselves out just by simply bouncing that interface. But as you can see, we did that transition over to multiple spanning tree protocol. And if you did it in the middle of the day, no. That would have been a bad scenario to be in the middle of the day. So even though we have backwards compatibility and we can transition, slowly in the environment and do it with very minimal disruption, as you can see here, in our small little environment, it would have caused huge disruption. So be mindful when you're transitioning over to multiple spanning tree protocol to plan wisely.